Hi, my name is Sandeep Gupta, and I'm the product manager of TensorFlow JavaScript. Today, I'm really excited to talk to you at the Chrome Developer Summit about machine learning in JavaScript. As a web developer, you may have felt that all this buzz and excitement about machine learning seems to require Python, and how you as a JavaScript developer can jump in and use machine learning. I want to show you that now machine learning in JavaScript is real, powerful, and useful, and you can do some amazing things with it. Earlier this year, Google released its first ever AI-powered Google Doodle. In this, users could synthesize a Bach-style harmony using a machine learning model running directly in their browser. So in only 3 days, more than 50 million people used this doodle to create, save, and share their music. A creative marketing team in Google has built a fun interactive experience where users are shown a zodiac symbol and they try to match the shown animal with a shadow of their hand, making that character come to life. Other teams are experimenting with novel ways of making web interfaces more accessible. In this example here on the bottom left, called Creatability, people can control web interfaces with gesture, such as playing a keyboard with their face motion. All of these amazing examples have been made possible by TensorFlow.js. TensorFlow.js is an open source library for machine learning in JavaScript. It runs in a web browser and can also be used server-side and on many other platforms that support JavaScript. You can use TensorFlow JavaScript in one of 3 different ways. You can run a pre-trained machine learning model in your application. You can customize a pre-trained model by retraining it on your own data. Or you can use the lower level ops API to write a new model from scratch directly in JavaScript. There are many reasons why you may want to consider using TensorFlow JavaScript. First of all, it allows web application developers and JavaScript developers to use machine learning directly in their applications, and it's really easy to get started and be up and running. With only a few lines of code, you can load our library and you can load a pre-trained model such as the BodyPix model. And this is a model that allows you to do person segmentation on an image. You create an instance of the model, and then you call its estimate person segmentation method on your selected image. And you get back a JSON object which contains the segmentation mask, which can then be directly used in your application code. That's all there is to it. So in just a couple minutes, you are up and running and you're using ML in your web application without having to deal with concepts such as tensors, optimizers, losses, etc. TensorFlow.js can be used client-side in the browser and other browser-like platforms. This has many advantages. You get all the benefits of the interactivity of web as a platform, and users can use directly microphones and webcams and other sensors that are attached to the browser. Users don't need to install anything, so your application becomes instantly deployable and shareable. Another big benefit is that user data stays client-side. And this has very big implications for privacy for applications such as healthcare, for example. And it also helps reduce latency and server-side costs. Finally, we support GPU acceleration through WebGL, which gives it excellent performance out of the box. Although in this talk we are mainly talking about browser use cases, I should mention that TensorFlow.js can also be used with Node.js server-side, and this is very useful for enterprise applications where Node is heavily used. So a natural question to ask is, how fast is it? Well, it turns out it's really fast. For example, on mobile devices, running inference with an image classification example using the MobileNet v2 model, you get real-time performance with 20 milliseconds inference time. And on server side, we have performance parity with Python-based TensorFlow. So to help you get started, we have a collection of pre-trained ML models for common ML problems that we have pre-packaged for you. These include use cases such as image classification and object detection, detecting human pose and gesture, audio models for recognizing spoken words and building speech command interfaces, and text models for text classification, sentiment analysis, toxicity detection, etc. It's really easy to use any of these pre-trained models with our high-level wrapped APIs from our hosted scripts, or you could install from our NPM packages. Using these models as building blocks, applications can be built for a variety of use cases. These include things like accessibility, AR/VR experiences such as virtual product try-ons, conversational agents, and moderating user-generated content on your websites. So these pre-trained models are a great starting point. Often, however, in real life, you need to customize these models on your own data. So one way to do this is again by using the power of TensorFlow, running directly in the browser interactively and using that to train a model on your own data. Let's take a look at how easy this is. So in this demo, I will show you how to use Teachable Machine to train a custom model. So the MobileNet image classification model is already running in this browser session, and we will modify it to recognize symbols for rock, paper, and scissors. So we're going to output the word rock for the first class. We will output the word paper for the second class, and we will output scissors for the third class. Now let's record the training images for these three classes. So first let's record images for rock. So I'll hold up my hand like this.
Rock.
And now let's record some images for paper.
Paper. Rock.
And now let's record some images for scissors.
Paper. Scissors.
And now our model is ready for inference. So let's take a look.
Rock. Paper. Scissors. Paper. Rock. Paper. Scissors.
So that's all there is to it. In a few minutes, you have a custom model trained in the browser. So far we have seen the capabilities of the library. Now let's take a look at some use cases. Modiface is an augmented reality technology company based in Canada, and they have used TensorFlow JS in the WeChat mini program platform to build a beauty product virtual try-on application for L'Oreal. Using TensorFlow JS, they were able to deploy a custom model meeting their model size and speed constraints for this application. And you can do the same thing in browser extensions. To showcase how you can enable amazing user experiences with the power of TensorFlow JS, we've built an application. Here, we are running a state-of-the-art machine learning model to track users' lips and face movement, and we use that to lip sync to a song and score how well you do. You get awesome real-time performance that enables this application, and because there are many JavaScript visualization libraries out there, we can use them to add on some cool special effects. So let's take a look. Companies are using TensorFlow JS for a variety of purposes, whether it be for internal tools for experimentation and visualization at Uber, privacy-preserving client-side application at Airbnb, and also offline mobile device use case for field use by IBM Research. Lastly, I want to highlight that the success of the library is due to our amazing contributor and user community. The library continues to grow in usage and popularity, and we are really excited about the amazing libraries that the community is building on top of TensorFlow JS to extend its functionality and applications. So thank you all. This was a quick intro to TensorFlow JS. Please do check out our website where we have more demos and examples and getting started guides and resources. And also from there, you can join our developer mailing list. Thank you so much for watching.